Hey there, grade six. New math video for you guys, new unit actually. This one starts with equivalent ratios. So it's a unit on ratios and percentages, I think is what it's called. It's one of the number sense units. So a couple of learning targets. I can explore how equivalent ratios are obtained through multiplication. The second learning target is that I can find examples of equivalent ratios. And so just a few prior skills required. You need to be familiar, first of all, with equivalent fractions, and then generally familiar with ratios, which we have sort of talked about before. So we're going to introduce this concept of equivalent ratios. And so where we're going to start is the fact that I love pancakes. And I have this recipe that calls for 6 cups of flour and 2 bananas. And so what I've done is I've drawn a little picture out that has 6 cups of flour and 2 bananas. So what if I only wanted to, or what if I only had 1 banana? How many cups of flour would I need? Hopefully, as you look at the left-hand side of your screen, hopefully what you see is that if I only had 1 banana, then I would need 3 cups of flour. So what I can do is I can write over here, if I had 1 banana, I would be able to use 3 cups of flour. So the number of cups of flour is always going to be 3 times the number of bananas. So if you know how many bananas you have, you can always figure out the number of cups of flour you need because you're always going to need to multiply by 3. So for example, if I had 3 bananas, multiply that by 3, I would need 9 cups of flour. If I had 4 bananas, multiplied by 3, I would have 12. I could have 12 cups of flour. Now these are, first of all, ratios. So it'd be like 3 cups of flour to 1 banana. So generally when we write ratios, we could say something like 3 to 1 or 6 to 2 or 9 to 3 or 12 to 4. So that's one way that we show ratios. Ratios are equivalent because they basically show the same sort of thing, just with different quantities, but they represent the same comparison. There's 3 times as much flour as there is bananas in this situation. Okay, so ratios are equivalent because they show the same ratio. So what you can do at this point is pause the video and you can work on the first 2 questions on page 117 for equivalent ratios, and then you can unpause it and pick up the stuff. All right, so where we move on to the next part of our lesson is finding the missing number in an equation between ratios. And so here I have a ratio of 1 to 4, and I have it equaling some number to 12. And so there's kind of a couple ways that we can do this. This one will for sure get you the right answer. What you do is you sort of continue the sequence of equivalent ratios until 12 is the second number. So what we could do is say, well, the first ratio is 1 to 4. My next one would be 2 to 8. My next one would be 3 to 12, right? And so basically what I'm doing is I'm skip counting, or I'm like 1 times 2 is 2, 1 times 3 is 3, 4 times 2 is 8, 4 times 3 is 12, which kind of focuses on the second point here about scale factors. I'll talk about that in a second. But basically what we're doing is saying then, well, 1 to 4 is an equivalent ratio to 3 to 12. They represent the same comparison, basically. If we're using scale factors, without trying to confuse people too much, I often show it in terms of arrows. So the first number to the first number and the second number to the second number in these ratios. In order to get from 1 to 3, I have to multiply by 3, and then to get from 4 to 12, I also have to multiply by 3. So that scale factor is how to get from one ratio to another ratio. And so some examples here, if I have 3 to 5, if I'm trying to get, I could say 3 to 5, then it would be 6 to 10. Every time we are going to be multiplying, well, to get from this one, we would be multiplying 5 by 4. If I use scale factors, it's probably the quickest way to get there. And then 3 times 4 makes this number 12. This one I want to get from 4 to 12, and so I multiply that number again by 3, which means that I would multiply this number by 3 if I use scale factors, which means that this number is 9. And then over here, to get from 3 to 15, I have to multiply by 5. And to get from 6 to the next number, I have to multiply this by 5. So that becomes 30. Now, what you can also do is write like a table, like we did on the last slide. So let's say we have this problem here, 3 to 5. I'll just set it up like this. 3 to 5. Right, and so here we would go 3 times 2 would give us 6, and 5 times 2 would give us 10. 3 times 3 would give us 9. 5 times 3 would give us 15. 3 times 4 is 12, and 5 times 4 is 20. So that gets us to that number, that magic number that we'd be looking at, right? And so this I hope this doesn't get too confusing, but each time from the first number to the number below it, so this would be 3 times 2, 3 times 3, and 3 times 4. Likewise, 5 times 2, 5 times 3, and 5 times 4. So you could do that with all of these as well. If you want, it says at the bottom of page 3 and 4, you can stop it now and work on number 3 and then pick it up, because what we would do then, the next one is writing ratios for word problems. And here's a couple of word problem-ish things. For every blank months, there is 1 year. Well, I know that there are 12 months in a year. So for every 12 months, there's 1 year. So the ratio then of months to years would be 12 to 1. So again, I'm taking a word problem and turning it into a ratio. Next one says for every blank days, there is blank week. So the ratio of days to weeks is blank to blank. Well, this one would have more answers. Let's start most basically. For every 7 days, there's 1 week. So then the ratio of days to weeks is 7 to 1. And again, at this point, you can use that information as well as the previous stuff here to work on number 4. You can pause it there. The last thing that we focus on is just solving word problems using equivalent ratios. And so what we would do then is, here's a word problem. They're kind of similar to what you would find in the workbook. But there are 2 red balloons for every 3 pink balloons at a party. If there are 8 red balloons at the party, how many pink balloons are there? The first thing we need to do to solve this problem is recognize that our ratio is going to look like this. It goes red to pink. Okay, so that's what we have to understand first. The simple ratio that we're given is 2 to 3. Right, and now we can just start skip counting. So 2 times 2 is 4, 2 times 3 is 6, and then 2 times 4 is 8. And I can stop there because I need 8 red balloons. So then I can use that information to find. So 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. And so here, if there are 8 red balloons at the party, then there would be 12 red balloons, or 12 pink balloons rather. And so all of the questions are kind of like that, and they're set up so for you to do this kind of thing. Don't worry too much about scale factors just yet. We'll get to that in sort of a later video. But at this point, you can work on number 5 in your workbook. And thank you for listening and watching, and have a great day, you guys.